something wrong about this. So hide this screen and then go to new. Yeah, I made a huge mistake here, assuming that that was true, but it isn't. So, all right. I'll choose the green one because it's basically unseeable. I thought it was possible, to be honest, but the Jacobian matrix turns out it's impossible to use a Jacobian matrix for something that's simply impossible. Okay, so what the color did I use again? Like this color probably. And then did I use that color? That's your question. I used black. Okay, so not I did the wrong color, but it's fine. Doesn't matter. DQ is what we're looking for. Kind of. That looks awful. No, I like using arrows. We should probably use arrows instead than DQ. The width is defined by something else. DS, I believe, which is infinitely zero. So we can talk about that later. But uh, I want. Let me bold it to 3. We want. Oh, this looks awful. Want E on the point P, and P is going to be over here. And let's just do the same kind of design we did for other ones. Yeah, make it a coin shape. That looks good, doesn't it? So now, oh, I don't explain that right here. So at point P, what's happening is that the because this is one uniform form, this usually makes. No, I should make a different color here. Usually makes something like this, and then the bottom over here maybe red. And um, let's see. And then let's just use yeah, red. It makes this color, which means it makes this a lot more bigger. It should be like 2 times bigger, as you can see. The reason is due to, you can do it this way, or you can apply it to, um, let's just do green, and then green, because they both cancel out, they're equal to each other. You can either do it that way, so we know that probably is an easier way to explain it, and then, you know, maybe this will be a more clear visual of what's going on. Um, kind of, so any 2 points of the wing can make this kind of angle velocity, and if you rotate this around and just choose another 2 opposite adjacent points, it will give you that same thing. So in reality, you could think of it as a bunch of that. What color would be good? Maybe purple. You could think of it as a bunch of this angles everywhere that make up this idea, because in reality the red, uh, maybe this is a little bit too hard to draw in the snippet area, but something like this, that yeah, you get it. And then the blue one, let me draw a little bit of this. and then blues like this, red like this. It's a helpful visualization of what's happening. So if that's the case, what did I do here? I believe I did an angle over here. So this angle um, is this angle. This angle would be sine as sine equals x. Oh, I should label what x and all that means. What did I choose as x? Although actually I didn't choose anything. X. So let's just say what x is because I clearly didn't do that. And then here, let me erase this and change this actually. When the Q is in a ring form, the charges are in the ring form. So we can now bring out some other colors. I mean, we can do this if you want. I don't think that's the color I want. Let's do orange. Square root of r squared. Wait, that's wrong. What? What was r then? I did something wrong. No, that's right. That's right. R squared plus x squared. Because we don't know what x is, but we know what r is. R is the radius of the ring. R equal radius of ring. With that knowledge in mind, you could do the rest here, which is I don't like the color of this at all. I think we'll stick with black. R equal the integral of, so it is KB because, and then it's the charges inside the ring. Q equal charges in the ring, obviously. If you're doing half a ring, it would be more difficult. I don't want to do that. Though we will not be doing that yet. I probably have to do that soon. It's just going to be a pain in the butt. And then we need sine theta, right? And then, but it is in dx form, right? It's dx right now. Recently, it should be in. No, it's not. It's dq. Sorry. It's a dq. Yeah, dq. Um, yeah, dq equal alpha dx. Alpha is the linear charge density. If uh, uh, go back to a moment of inertia. I don't like how it goes back. Go back to moment of inertia or CM with density and its and understand the idea is the same. So we get over here the little bit of explanation on what the idea is for um, so this linear charging. Um, I wrote down somewhere over here about the different 1D and 2D. So let me write that. O for is 2D charge. We don't need to do that yet, do we? I don't know. Is alright. Really want to do this like this? Yeah, I do. But we need to stick with this one too, actually. So we need to do some q divided by square root of r squared plus x squared, and then you can just change sign to times by x divided by what was it again? X is this direction, so sine is this direction. Sine is opposite over adjacent, so it's actually the opposite way around. What? That shouldn't be true. Did I fuck up? You know, I'm right. I'm right. I'm right. So it's x divided by square root of r squared plus x squared. Um, Surely I'm not tripping. No, I'm not. That's right. And then, um, oh, I'm being a dodo brain. So, okay, so that makes sense actually. Okay, so we have this too. Now, ER theta integral of KB linear charge density is ds dx. Okay, so x linear. Does the linear change density change? Oh, so so charge density also means it is q divided by s uh, if uniform. So it's like same thing as uniform density. Let me if uniform, and then did I get that right? I think q divided by s. Yes. Uh, s. You'll find out what that means later. Mm, actually, right now, actually, when I finish this shit. Um, and then so no, 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 don't say that. I need to change this over here to q divided by s ds over here because I'm changing that to this divided by 1 square root of r. I am not doing that integral, by the way. If you want to do that fancy integral, go ahead. I'm not stopping you. I just don't want to do it. Um, okay. So you can understand what this is. Okay, so maybe I should explain that sine theta equals x. I think they get it. It's a rectangle form, but I want to put it down. Not that color. This color do good. X divided by the square root of r squared plus x squared. Uh, that's just a property of, you know, important property because that gets rid of that. Okay, what else did I put in here? Um, oh, yeah, there's also the square. I forgot. Square. So erase this. Erase that. Erase that. Sorry, but you don't belong there. That's due to the properties of uh, Q charge. So if you know about how um, it works is q on the top divided by the linear graph over here. So it makes perfect logical sense. It's just that I personally don't like it. Um, yeah, that's all it is. Yeah, because you need the distance over here. It's let me wrong one. I want the eraser over here to make this more clean. I totally forgot about that property down there, so I need to make this a little more cleaner. Yeah, that looks better. R squares like that. Yes, that's perfectly fine. Now I need to change this into a more edible piece of divided by 2 pi r, because if you unfurl that line, it's 2 pi r, right? The circumference is 2 pi r, it's linear charge density. So as you know, in moment of inertia, we did the cancellation similar to that. Go back to that, and you should understand what the hell I am doing. 0 to 2 pi r, and then we just need to do the x by the parentheses r squared plus x squared 3 divided by 2 ds. So now you know that the ER, why do I always make that mistake? ER is equal to KB divided by, because the 2i squared will cancel out if you do that derivative. It's just this. It's not. Oh, I'm not gonna get it. Okay, fine. And that should do the trick. I got the same answer, so yes. We unstretch the circle. So this circle, uh, note, we unstretched. And how do you spell unstretch? I'm just gonna make. Let me get my phone out. How do I write unstretch? Unstretched. Unstretched. We unstretch basically. That's how I think of it. Stretched. Stretched. A circle to linear. So 2 pi r is the tiny idea of it. So basically, what's happening, if you think about it, is we unstretch to a line, and we make this over here as square root of r squared plus x, but this point in the same place is what we kind of did. Technically, we did a little bit more than that, but to you kind of get the idea of what we did. So I hope that's good enough. Um, um, so S basically means length uh, in the, you know how an angle is? So length uh, definition. Let me go to the definitions. I need to be careful. Definition of angle. It's not sin. Okay. Definition of angle. Where is that? If I can't find it, then I won't tell you it. But it's oh my god, I can't find it. Arc length definition. Here it is. Uh, so basically, S equals R theta, right? kind of is the idea we have here, r theta, um, 2 pi r, and then the r linked to the